Go ahead.
Hello, welcome to this week's Maker Meeting from Workshop 88. Each week, we explore projects that our members are working on and topics of interest to our Patreon supporters. Our Makerspace workshop primarily serves the western suburbs of Chicago. These meetings are about the opportunity to interact with a community of makers. We learn by sharing and asking questions. If you see the value or have something to add, then you should become a member no matter where you live. Membership includes access to our Slack channels for even more discussions on a variety of topics. Tonight, we're going to hear about people's learnings and experiences with OpenSCAD and FreeCAD software in a feature-specific sort of way. So for a more basic introduction and overview of these software packages covered tonight, visit our YouTube channel for the February 9th, 2021 episode. But for now, take it away, Bob.
Okay, thank you, Gail Joe. Let's see. I hit a button here, we might change things a little. Good, there's a screen. And if I click here, we can talk about the OpenSCAD Customizer. This is a feature of the OpenSCAD 3D design system. So you really kind of have to understand what OpenSCAD is before we can even talk about what this customizer is, right? So OpenSCAD is really a programming language that when the program is executed, you get a 3D model. In very much the same way that PostScript is a language, it's a Turing-complete language. You can use PostScript to write Mandelbrot things. Well, bad example. You use PostScript to, solve the 8 queens problem. But what PostScript really is good for is that a side effect of running the PostScript program is you get black marks on a piece of paper, which is what pops out of a laser printer with PostScript. And in the same way, when you write OpenSCAD code and run it, you get a 3D model, which you can export as an STL or a 3MF or however you want to do it. And so really this OpenSCAD customizer does is it provides a GUI for setting the variables, which are going to go into your OpenSCAD program so that you get a model coming out the other side. And it really allows you to change the way a model renders without changing the code of the model. So what's it good for? This customizer is useful when you say want to select from a menu. Would you like to have a cutout for a VGA adapter or a DVI adapter or an HDMI adapter? They're each a different shape and size, right? It's good for conditional viewing, especially in a complex model. Pieces of the model can get in the way of some of the other pieces. So you might want to, just in a Boolean, turn off the pieces that are in the way so you can see through the spots of the model that you're working on. I use it frequently to assess fit with related objects. So I'm trying to look at something on the screen. If I've got a widget and a Dumaflotcher, I want to see if there's enough room to get my fingers in between the widget and the Dumaflotcher, and I can sort of change the size of one or the other or the space between them, and then sort of make a good guess if I can get my fingers in there or something like that. You can take a look at aesthetics. You can sort of set a number and see when proportions look good or how many ventilation holes look good. And lots of sort of what ifs, very much the way you'd use a spreadsheet to say, well, what happens if I retire sooner? And what happens if my income goes up? Or what happens if it goes down? You can do all those sort of, questions about how things might come out, just change the numbers, see it on the screen, and decide which one you like. So the OpenSCAD customizer is built into the Thingiverse website. And one of the things the customizer is good for is that in fact, what you're seeing over here on the left of this screenshot from a browser is these are drop-down menus provided by the customizer. And the guy who wrote the model had to put these choices into the model to say, well, I'll show you. So, but this is basically a thing which shows wall plate covers. So this was me actually using the customizer earlier today, and there have been some times in the past when it was broken, but the Thingiverse customizer was working for me today, but not in Safari. It only worked in Chrome, and even though it sort of detected I was in Safari and said, "Oh no, would you like the Safari fix?" Even when I clicked the Safari fix, it wouldn't work. But going in Chrome, got it there. And the other thing I noticed is that you can always run OpenSCAD on your desktop. So if you see something on Thingiverse and you want to use the Thingiverse customizer, you can just download the SCAD model from Thingiverse. And then, in fact, I'll show you, because that's what's coming up next is a live demo here. Let me make sure I know which way to go to get to the live demo. Okay, the live demo is to the left. So this is that cover plate thing from Thingiverse. So you can recognize that as a standard sort of cover plate you'd have in your house. And the first question that you want to ask is, how much space do we need? I cranked it up to say what they call, I think electricians call it 3 gang. And then you can make what the electricians I think call a goof plate. If you've goofed up the drywall around there, you can make it a little larger or standard size there. I tend to use goof plates a lot when I make a mistake in the drywall. But then you can sort of pick like a toggle switch here, and then you get a toggle switch on the left. And maybe for the second, we'll put in like this would be one of those like a GFCI. And then what else we put in? Duplex outlet. Yeah. So I'm just picking things off this menu on the right. This is the customizer menu, and this is live. I mean, I can still do everything I want to do in the model. And as I change it, I can switch to a different kind of make 2 outlets. Right. And so this is the use it from a menu thing. It's very nice. Yeah. And the code isn't actually changing. It's just the variables being driven into the code. And I think this doesn't have any presets, but you can imagine presets could be in there for like 2 outlets or 3 switches or whatever. And then you can just choose from the dropdown. Any questions on that before we go on to the next model? Okay, none heard. So here's an example. I think I showed this tweeter mid-range. Well, I guess my camera's fighting that, but this is a real mid-range horn, and I've got several of these, and I wanted to figure out how to combine them. So I made this model showing, this is the picture off the website, and this is the model I made in OpenSCAD for this mid-range horn. And the questions were like, if you have many of these horns, do you want them at, steeper angles or more shallow angles? And, will the back sides bump into each other if you combine them at different angles? So I wanted to use OpenSCAD to do that. And I'll show you how that worked out. Here we go. So here's that mid-range tweeter in a model moving around. And what I put in for the choices on OpenSCAD were, show the mid-range or not. This is Boolean. And of course, there's nothing there if you don't turn that on. But the idea is I was going to mount these in a, what I call it a wall segment. So you can see, that's the inside of the mid-range there. And the question is, when you have not just one wall segment like this, but you can imagine several of them, how do they interact? And also, how does the size of the wall segment interact with that? So I put a slider in here. So you can set the width of the wall on the x-axis. This just effectively makes it thicker. You can see the wall getting thicker. This sets the depth of the wall, which really is kind of into the camera at this point. So you can make things very wide. And this is just the height of the wall, makes it taller. And I've got the model set up so that it always finds the center point and puts the mid-range horn in the center of the wall, wherever it may be. But this is the reason I took the time to do all this in SCAD, was that I wanted to be able to do things like have more than one wall. So here I just clicked the button, and I'm going to zoom out a little so you can see this. Now I've got 2 of them. There we go. Slide that over. Oops. I'm not as good at, and we can set it up to like 3 or 4. Yeah, there. Now I've got 4 of these things. So this is a model with 4 of them, and I can see how the aesthetics look like that. But I can also see things, say, when I look down from the top, I can see I've got plenty of clearance between them in the back. But if I change the depth of the wall size here, if I make the walls smaller, you can see the magnet structures get closer and closer. And if I make them too small, I reach this point where they start bumping into each other. So that tells me that my minimum wall size should be like 178, millimeters, something like that. And this gets even more interesting if I go to the tighter angle. If I use the 60-degree angle, then you can see that I really have to make those walls longer to avoid quite a bit longer, actually, there, to get enough space between them. And I could have figured this all out with trig. Or, well, my math teachers would be disappointed that I didn't figure this all out with trig. But I decided to take the easy way out. And you can actually see how some of this code works over here on the left. This is the actual code. So these are just Booleans saying, do we show the walls? Do we show the mid-range? This is saying the wall segment width and depth and height. And this comment is actually setting the limits on the sliders over here to the right. So you can set limits and the number of wall segments, will only go up to 8, but that's just arbitrary. Although, of course, your model will break at some point. And so the guy who's designing the model and wants to provide this as a service to somebody who has no idea how the code works, they just want to, look at these knobs and set them to a particular spot and get a model that they need. They have that choice. The last thing that's sort of worth looking at just briefly in this model, I think, isn't really about the customizer at all, but I wanted to mention it. This is the code that actually renders the mid-range driver, and that's way too complicated and uninteresting. But the actual code to do the wall is right here, one of these wall segments. So this is the really main line, just says for, I equals 0 to the number of walls, do a wall. And this wall is actually recursive. So what I'm trying to do here is imagine the origin is at this point to draw one wall. And the way you get, all these walls drawn is by, doing what I believe is called head recursion. Check me out if I'm not tail recursion, Scott, I think. But anyway, the point is you render this guy first after, recursing 3 times to get to this guy, render him, and then you back up and render the others, and then you're done. And you get a nice model without having to write any iteration except the main line here. Okay. Any questions on that before I go on to the next OpenSCAD?
Okay, Bob, do the variables, can you do that with local variables or?
Well, there really aren't variable scopes the way you'd think in OpenSCAD, because variables aren't like, it's kind of surprising, Scott, how long I used OpenSCAD assuming that variables were just like variables in any programming language, and I could change them, but they aren't that way. Can you say any more about why you would want to do it to a local variable and not a global?
No, I think the user interface components in the customizer are only available to global variables.
Okay. And I thought all variables were global by definition, but I could be wrong.
And
they have to be at the top, that I know, right?
Yeah.
So this, and you need this this kludgy thing in here, like a module called end customizer that doesn't do anything. Turn off the customizer and say, stop doing this other stuff.
Yeah.
Okay. So, all right, let's see. That's second live demo. So the next, I have to tell this as a story. Again, I'm using a lot of these little battery holder MCUs, and I was working on a project with these things and trying to get these to fit into a case. And as here, I'll stop this for a second and show you the cases, because that'll make things a little more clear. Okay, so this is the case for one of these projects, and it's pretty thick, right? And you can maybe see there's a USB port on the back there, and there's a little switch in the corner here. And that's because this MCU fits down, I don't know, like that, fits inside there. And the switch pokes out through this little notch, and the USB port pokes out through a hole in the back. And I wanted to improve the fit, because this is kludgy, basically, sticking your finger in this little hole to find this. It's a small switch anyway. And the fundamental problem here is that the front of this thing, or the top, if you will, needs to be about 50 millimeters here, but this is only 26 millimeters, the MCU. So the question is, how do you get this wide thing to go down, because you need to have access to both the USB port on one side of this, right, and the switch on the other side, and the case is too wide for it. So that's why this was notched out in the corner there. So that's sort of the fundamental question. And while I have the camera wide angle too, I'll show you, this is the way it came out in the end. And in this case, it's nice and thin. You can see the difference between these. And it's really OpenSCAD that was the secret to making all the improvements that got me from this to this. So back to it, and I'll explain how that came about. Oops, wrong. You have to click before you clack. There we go. So plan A for how to adapt 50 millimeters down to 26 was that sloping corner I just showed you. And the bad news there was, that's a screwdriver, which is basically what you needed, a tool to stick in there. And the MCU you can see down inside the case, and this is the notch from the top and the notch from the side. And of course, what's driving this is this overhang here, right? So you can't make this angle too steep or the printer can't print it. So that drove the height, and I was trying to make something a little thinner, as well as thinner in this direction, and I was limited by the slope there. So plan B was what I called a dent, and I'll show you the OpenSCAD part of that. But this is the dent for the USB side, or excuse me, for the switch, and this is the dent for the USB. So the idea was to put a little bit of the put the MCU kind of in the middle of the case, and then have a dent in for each side. And that was really where I first figured out what the customizer was good for, and I'll show you that. Okay, so this is crazy small. Let's see, dent height. So this is closer to a real dent, and this doesn't have the hole in the back, but the idea would be you'd cut a hole in here for the switch or the USB, and that's what the dent looks like from the back. So this was just a little isolation. I made these two L shapes to simulate the bottom of the case and the wall. And then I could do things like vary the width and sort of figure out how much width I needed for my finger or for the USB port. And how deep it had to go based on, that's very deep. This is, very shallow. And you can see how that changes the angle of that sloping roof, I think I call it, or something, as you make the dent go back more and more in depth. And then this back wall height is this is called the back wall back here. So if you needed a taller thing, then that's going to limit it. And here's your height. So this, once I, when there you can see the printer will never do that. At least my printer can't print that long a span at that kind of an angle, right? So I was able to make a certain amount of design decisions in 3D before I ever even got to the printer, which was very helpful to me. And that sort of sold me on the customizer. Any questions on that? Because there's not much to see in the code on that one.
Actually, I got a quick question.
Sure.
So are you saying that in your OpenSCAD code and within the customizer, you have parameters that are adapting based on the angle that your 3D printer can print without supports, or is that just something that you kind of know anyway?
Yeah, I glossed over that. So it's essentially I'm eyeballing it, but I don't have anything in the model. I could, but for instance, if I make this width small enough, right? So I make it very small, then I probably have the ability to bring the height down and go to a much steeper angle, right? Because now you're not stretching the filament over as wide a distance, right?
Right.
And
Okay.
even just there's an insight to that I had probably missed until I started. It's one thing to have to rewrite your code or change a variable in your code and wait for a render, as opposed to this, which is just immediate feedback, and you kind of go, oh yeah, well, the height and the width and the front and the back, they all have their role in deciding if this is printable or not. And that sort of led me to like, how close should I put it to the front versus how close should I put it to the back, and how short can I make it? So I figured it out.
Yeah, very cool.
Okay. Anything else from anyone? No? Okay, I'll make sure I didn't miss anything. Yeah, so plan C was the idea of a slide. Because really, the dent thing, even though I built it, and I built some cases with it and printed them and built a few models, the exercise made me think about what I was trying to accomplish. And I realized that I'd sort of phrased the problem wrong. That I phrased the problem in terms of this being narrow and needing access to one side for the USB and the other side for the switch. But as I thought about it, thought, well, what if and I didn't want to extend the USB and I didn't want to extend the switch. So what's the other choice I have? Well, don't use the front and the back, use the bottom. That was the key insight. So I came up with this idea of this orange piece in here called a slide that I decided to call a slide. So this is one of the microcontrollers sitting outside the case. There's one inside this case here in this same region. So these line up. That's the same USB port. And what I did was just cut a hole in the bottom of the case. And these orange bars are part of this slide that are grippable, I'd call it, through that hole. So you can put your finger in there. You don't even really need a fingernail. There's just enough. It's a big enough space. That's the size of a ESP8266 MCU. And in fact, the slide is resting on top of the CPU package. It makes a bearing point, which works just fine. And this is the same thing flipped over from the bottom. And you can see that this slide thing, the orange thing, just grabs the switch. And by sliding it left and right here, you're moving that little toggle switch left and right, which turns things on and off. So I redefined the problem away from trying to get the edge to match the USB and the edge to match the switch by just saying what I want to match is an edge in the bottom. It did mean I had to put some dabs of this is hot melt glue on the corners because you're basically your finger is pushing up against the MCU to slide, so you have to glue it down. But this changed everything. Among other things, it meant that MCU now I could take off the 18650 battery holder, and these are just a couple of LiPo batteries. So that's how this whole thing got to be thin, was I got rid of the 18650 and went to LiPo. And that really improved the design tremendously. And now where does all this come back to the customizer? It's just the customizer sort of let me see it before it happened. And this is the way it came out. I never went so far as to actually make the slide, but you can see some of the things I went through here. So the slide, that's if you want to print a slide. Here's one I wanted to show you. Oh, that's the MCU, right? So what basically the big yellow thing you're seeing here is the tub, the case in which this all fits. Where's the slide? Here's the slide. So there's the orange slide. And you can sort of see that the finger would come up through this hole in the bottom and press that orange slide. And then as the finger moves back and forth here, you're moving this frame around the switch, and that's what causes the little switch handle to move. And you can preview the batteries. That's what the batteries look like when they're in there. And then I also put in the MCU itself. So there's an MCU board, and you can sort of see the slide peeking out from underneath it like it did in real life. The last thing I think might be interesting to see on this is I flip it around. As you look in this hole, this is where the USB port goes. And I'm going to zoom in here a little. This little gray thing, I took the measurements off the MCU, and that is the actual position of the USB port on the MCU itself. So this let me do things like fix the, I can see that's way too high, but I could set sort of the minimum and maximum height. Yeah, that's probably about as low as I'd want to go. And I could go too wide, or I think I just set the parameters on this. That's probably too narrow. So basically this let me fix, and I'm sorry the rendering isn't perfect here. Sometimes the walls turn transparent and it's a little hard to see in preview mode what's going on there. And yeah, well, there you can actually see the, what's that? Yeah, the slide poking through from the bottom there. So anyway, I was just thrilled with how this came out, that I could see all this in space before me, before I ever saw it pop out of the 3D printer. And I was reminded of a quote from Mr. Spock on Star Trek. I'm dating myself. When I grew up, one of the Star Trek episodes, he was watching some primitive culture, attack the Enterprise. And he said, well, they have crude methods, but they're effective. He had to admit that. And that's kind of the way I see this OpenSCAD customizer specifically. Scott mentioned some of these limitations already. It only works at the top of the file. It only works in the main file, not it includes. And it needs this dummy Sentinel empty module before the things you want it to ignore. And this horrors to me that, a programming language has comments which are meant to be read by humans. And here's a programming language where the comments are read by the language, which is just horrors. But this is part of the crudeness, but it's very effective, and it's something they can sort of glom on after the fact, and it's very useful. And it really only makes sense if you already think like a programmer. And it'll be interesting to see Peter's contrast. But to me, it's hard to use OpenSCAD and even to think about things like recursion if you can't already think like a programmer at least one day a week or something like that. I forgot to ask if there were questions on any of the other stuff.
I just wanted to say I really like your final switch solution because you didn't touch on it, but you fully constrain the throw of the switch. No one can break the switch off or break it off the circuit board.
Yes.
That's good.
Yeah.
And I'll second the use of the customizer. I do a lot of OpenSCAD work, and without having the customizer, the alternative, my strategy is to turn on animate and then just manually type as fast as I can and have it continuously render for me. So the customizer provides a little more control, especially if you wanted to put it in other people's hands. So
yes,
yeah.
Those are great uses. Yeah, and so there's an example you can see it, Scott, where it's constrained. You're going to bump into that post, you're going to bump into this edge down here. So there's just no way to break the switch. And that took a fair amount of fiddling, plus 0.5, minus 0.5 until I got it. Okay. So just last slide, general advice on OpenSCAD. I imagine you have the same advice, but for me, I just have to be super clear for the benefit of my future self that I'm very clear about which way is X and which way is Y. And I always use a suffix like X, Y, or Z and a, width, depth, or height, to match with that. And so that, things line up. I never should be subtracting a width from a length, that's a mistake. Or, you shouldn't mix Y's and height or something like that. And locating where the origin is, especially when you're doing like this recursion, you got to keep track of where the origin is and where the axes are at each of those points. Because when you call a module with recursion and the origin has moved because you translated or rotated, and just like naming the components is just super helpful. And like in that, I had a name for the horn piece and another name for the magnet piece and the throat of the horn and the it makes the code readable essentially. Okay.
I will add a tip if you ever get confused about your what your orientation is. There is an exclamation point.
Yes.
Which will just draw that item or whatever that subtree is, and you could sort of figure out what you've done if need be.
But it draws it at the origin, I believe. Yeah.
But at least the axes will be lined up. You could look at the colored axes in the window.
Yep. Yeah, that's a good tip. And the pound sign is the other just super helpful thing. It makes it colored. Yeah, I could demonstrate that if you want to see it on those models. I had to do that. Yeah, that's not really part of the customizer, but it's a good. Here we go. Oops, no, wrong screen. Oh, there. So that's a better. Yeah. So maybe I can find a piece of this case. Like, let's highlight this piece with a pound sign and see what happens. How do you render that? Is F5? Yeah, okay, so that's the piece of the floor there. And if I change that to a pound sign and render, then I only see the floor.
Exclamation point, yeah.
Oh, I'm sorry, yes. Okay.
Thanks for demoing those. They're hard to describe.
Yes, they are. Very useful, though.
Very cool.
Yep. Take it away, Peter, I guess.
Unmute. There we go. Okay, so yeah, I was going to demonstrate something that I just learned recently in FreeCAD, and it's not exactly like the OpenSCAD customizer, but I think as we go through it, you'll see why I think maybe there is a little bit of synergy there and why it's used for perhaps some of the same sorts of problems. And I'll give the caveat that I'm pretty new to FreeCAD, and I'm especially new to this workbench. So I'm sure that there's probably people who would find other ways to do the same thing, because FreeCAD is so powerful that there's often multiple ways to do the same thing, and maybe there's better ways to do things. But this was just a particular problem that I ran into recently, and it turned out that the spreadsheet workbench in FreeCAD was a pretty good way to tackle that. So I thought I would just share that briefly, and we can kind of see how that compares to what we just saw in OpenSCAD. So the problem I was working on is I had this thing which I've talked about at previous meetings, where I have this this flag that I put on my garbage can to show to tell when the garbage has been picked up by the garbage people. And it actually consists of two parts. It's got an extrusion. It's got a sketch which is extruded to make this part, and then just a plain cube which is tacked on to make the little flag part. But what happens is, if we just look at the sketch, I have it has a bunch of dimensions, and the thing is that in this particular, the way this works is this inner ring of the whatever you call this bottom part of the sketch has to be exactly the right size to fit over the handle on the garbage can. So I have one that fits my garbage can and one that fits my recycling can. And Gail Jo asked me if I could make one for her, and in order to do that, she had to give me the dimensions of the handle on her garbage can. And I don't remember what it was, but let's say I decided that I needed to change that from, say, 23 to 25 millimeters. And then as soon as you do that, there's other things you have to do. Like, if I want the thickness of this out, if I want to have like continue to maintain the 4 millimeter thickness of that ring, then I have to go in and make some other changes. Like I need, since I added 2 millimeters to the inside diameter, I need to go and add 2 millimeters to the outside diameter. And there we go. I thought I was done. So I shipped that, and I rendered that and sent it to Gail Jo, and she printed it out, and she said, well, how come there's this little gap here between the cube and the extrusion? Did you do that on purpose, or what? And I said, oops, I forgot that that when I changed that outer diameter of the ring, that it moved this face, and therefore I should have gone in and moved the position of that cube a little bit to get it to line up with the other part of the flag. So I started saying, there's got to be something in OpenSCAD that will let me address this kind of problem. And there probably are other things to do, but one of the things I found was this spreadsheet workbench. So what you can do is you can create switch to the spreadsheet workbench. You can create a new spreadsheet. You can edit that spreadsheet, and what you get is a typical spreadsheet. But you can put values in there. Like, let's say one of the things I want to change is my inner diameter. And I wanted it, in that example, I wanted it to be 25. So you don't have to do this, but one thing that's really handy to do is to change the properties on that and give it an alias, so that we can refer to it by its alias name, which I'll call ID for inner diameter, without having to remember where it is in the spreadsheet, and especially if it moves around in the spreadsheet. So once I have that in my spreadsheet, then I can go back and change this value, which I originally hard coded. I can tell it that I want it to come from the spreadsheet. Just select that, and I could have said, like, I could have just said I want it to come from B1 if I happen to remember what that is. But I can also say that I want it to come from that ID cell in the spreadsheet. And as soon as I do that, now that 25 millimeters comes from the comes from the spreadsheet. And if I want to change that, let's say I want to change it to
29.62.
yeah, okay. Let's say I want to change it to 29.62, and then go back and look. Actually, I'll look at the sketch, and there we can see now this ring is getting kind of thin. So I really need to bump up the outer diameter as well, but I can let my spreadsheet help me with that. So if I go and look at the spreadsheet, oops, wrong one. I can pick something else. Let's say I want to control the thickness of all my walls. I'll make that 4, and I'm going to have something that I'm going to call the outer diameter, which I can now say is going to be, it's going to be the inner diameter plus twice the thickness of the walls, because that diameter is twice that wall thickness, B1 times B2. And let's see, what did I do wrong? Yeah, so now that outer diameter is going to be that funny number. But I can give it an alias, which I'll call OD. And now I can go back to my sketch and say, instead of fixing this at 33 millimeters, I'm gonna make it I'm gonna try to make it spreadsheet.od. And now I have 4 millimeter thick walls all around. But I still have, and I could have, and if I got fancier, I could do other things with that to control the other walls and so on. And I did that eventually, but I'm not going to show that for this demo. But I'm going to show that I still haven't solved my original problem, which was getting that flag to line up. But one of the things that we can do is when we're controlling this cube, one of the things we have is the placement of the cube. And it turns out that the X offset of that cube was just right when I had a 33 millimeter outer diameter, because the offset from the origin is half that diameter, so half of 1333 is a negative 15.5 offset. So now I can let my spreadsheet help me out with that. So I can say the placement of that cube is going to be the negative of the outer diameter divided by 2. And then I can go back to the placement of my cube and say that I don't want it to be, I forgot something. I forgot my own instructions. I should have given that an alias so that I can refer to that by name. I'll just call it cube. And now I can go to the placement of my cube. And instead of making it 15.5, I'm going to pull in a value from my spreadsheet. And I'll make that the cube offset, and put that in. And now once I get things to redraw, then now my cube is exactly lined up with the face. Nice. And if I ever want to go and so, well, let's see. I'll show the end result now. So if I how can I guess I don't really need to save any of that. So I'm just going to close all that, because I'm going to cut to the chase and show you after doing that and a bunch more similar things, I created a fancier one that has a lot more stuff in the spreadsheet, including some reminders for me, like if I ever want to build another recycling can flag, I know that my inner diameter is 28 millimeters. If I want to build one for my garbage can, I can change that to 23 millimeters. and then go back and look at my I can just change it for make one, that matches whatever I need. So now that I know how to do this, I can see a lot of other applications for that, and I think some of them are the things like we did in the customizer. When you want to just play around with things, you can change these values. One of the things I found is that, like, if I'm putting, for example, I have a flat plate that I want to put screw holes in the 4 corners. I found myself in a situation where I have to put in the X and Y positions of each of those 4 holes. And if I ever want to change them, then I have to go and change all 4 X coordinates and then go change all 4 Y coordinates to get those 4 holes to line up. Now that I know how to do this, I could have done it this way. I could have had one dimension that gives the offset of the origin from one hole, and then just use that to fit in the values to automatically move the other holes around to match. So like I say, I'm far from an expert on this. I'm just starting to play around with it myself, but I thought there were some interesting tidbits there that might possibly be of interest to other people. So that's a whirlwind view of the spreadsheet workbench in FreeCAD.
That was great. Is that something that I don't know much about FreeCAD? I'm looking forward to finding some time to dig into it. Is that something that you couldn't do with constraints, or is this something to use with constraints? Or?
Constraints work within the sketch. And actually, I don't know, maybe this is just my knowledge. I don't know much about doing constraints that are functions of other constraints. So I could make this, I could have a constraint that said, say, maybe the difference between these 2 radii has to be 4, or has to be a certain value, like 4. But I don't know how to make it, like this value plus this value, or something like that. But maybe there are ways to do it. Another thing that I explored was FreeCAD has some things to link faces together. So you could do something like, you could say, I want to draw a sketch which is linked to this face, and then it'll move around as anytime you move the dimensions of that cube and change the face. But it turns out you can't link something to a face that is constructed by an extrusion. So that was the first thing I thought, was I would just link this face of this cube to this face of the extrusion, and it would happen automatically, and that didn't work. But the spreadsheet lets me do all these other things too. Like I can make the width of this opening depend on the diameter, and I can make other parameters depend on it based on the formulas. So I think there are definitely some things that you can do with this that you couldn't do simply with constraints.
I think it's fascinating to see I guess I've never used FreeCAD, but you can tell that the designers took the visual model first and then retrofitted the spreadsheet onto it, right? And the formula editor and all that other kind of stuff, right?
I think that's true. Yeah.
Yeah. And in the same way, you can see that OpenSCAD started out purely programming, and then they retrofitted on this customizer thing to try and, give back some of the stuff you lose because you're not directly manipulating spheres and things like that. Mm-hmm. So it's and in fact, I want to real briefly, something I meant to say on a slide here. What is the customizer good for? One way to explain some of these things that the customizer is good for is making up for other faults in OpenSCAD, because the customizer makes it a little easier to assess how things fit together. But one of the reasons you have to assess how they fit together is because you can't see it directly. You know, with FreeCAD, it looked to me like, you know, when you want to draw something, it's just right there. So you're always being, you know, assessing the fit, right? And the aesthetics. You're always looking at the way it looks. You don't need this afterthought, and you're constantly doing what if. So at least these last 3 bullets here to me feel like OpenSCAD is, or the customizer is, sort of making up for the fact that there's a programming language first.
I think that's an interesting observation. I think they're kind of looking at the same problem from opposite sides of the coin, but ending up at the same place.
Yes. And so I guess one way to look at it is, if I knew before I ever started designing anything that I wanted to, you know, I'd been to the hardware store and I'd seen the, you know, there's 10 feet of shelf space full of cover plates, right? You know, for every kind of combination of cover plate. And I'd say, wow, what I need is one model that will make anything in those 10 feet of shelf space, right? I would not want to do that with FreeCAD, no matter how many spreadsheets and other things, right? You know, SCAD would be much better for that, I would think, right? But on the other hand, if I was an artist, you know, who had no idea what the model was going to look like until it was done, you know, and I was driven by the instant feedback, I would want to be working in FreeCAD and not have my art interrupted by the square root of 2 and all this other crap that you have to do. And
I think that's right on target.
Yeah. It's like there's no such thing as a good tool or a bad tool. There's a bad job for a good tool.
And there's never just one tool that does everything you need.
That's right. Without giving you
you
blisters.
should check out my video blog. The tools I had to use there, but that's a different thing. Yeah.
Okay. So that's probably it.
Awesome.
Thanks, Peter.
Yeah, thank you, Peter,
Yes,
and
thank you.
thank you, Bob.
Sure.
Is there anything else anyone wants to mention really quick? All right, so thanks everybody for watching us again, and please like, subscribe, find us on Facebook, and follow us on Twitter. And we really appreciate all of you, and please consider supporting us on Patreon. Thanks, everyone.